Hello and welcome to IGCSE Physics. We're going to look at liquid pressure in a closed system. As you remember, in the previous chapter we said that pressure in an open container is equal to density, gravity, height, and basically how deep under the surface of the liquid you are. So the pressure depends on the depth. Okay, but that's when the system is open. When the system is closed, there's a new thing that comes into play here. Now, if I fill a container full of water, water particles cannot be compressed. Okay, so since it can't be compressed, what we have is if I've got a container, let's imagine I've got a bottle, plastic milk bottle full of water, and it is sealed. Okay, doesn't even have to be full. The fact is that this is compressible. Okay, because this is compressible and nothing can escape if the system is closed, I have, well, let's say in this case it's all liquid, I have the same amount of pressure in all directions. So in a closed system, pressure is the same in all directions. So if I apply pressure at the top, the amount of pressure that I will be applying will be applied to all the particles. So I'm pushing the particles of the liquid here, which in turn is pushing all the particles on the side of the liquid. So we have the same pressure throughout the liquid. Okay, and this comes to a topic of study with hydraulics. So hydraulics is when we apply liquid pressure in closed systems. We apply it in earth moving equipment. We apply it to your car's brakes. Okay, we apply it to a lot of other places as well. Car brakes is actually the example that we're going to be focusing on today. So here in your textbook on page 70 is a typical braking system, hydraulic braking system. And we can see that in your car we have what we call a piston. Now a piston is the place where you pump your pedal and that pushes onto the oil. Okay, your system is full of oil or brake fluid which is incompressible. So if I apply pressure here, okay, let's call that pressure 1, then on this side at your car's wheel there is going to be pressure 2. And we know that because it's a closed system, the pressure is the same throughout. Okay, so since pressure 1 is equal to pressure 2, okay, force over area then on this side must be equal to force over area on that side. Okay, and because we can change the areas, we can control how much. So if the areas were the same, the forces would be equal. But we know that if you have to press with your foot against the tire of the car, your foot is not going to have enough force. So what we want to do is we want to use this and manipulate it. So what we'll do is we'll have a very small area here and a very large area there. Okay, so that means that because I am changing the areas of the cylinders, okay, making a bigger cylinder here and a smaller cylinder there, okay, small force over a small cylinder gives me a pressure, and then it applies with the same amount of pressure a big force over a big area, and then I can physically manipulate, increase my force which I used to stop the car. So here in the textbook they do explain an example like that. They say that you've applied 12,000 Pascal to or basically 12 Newton to an area of 0.01, which equals to 12 or 1,200 Pascal. Now the pressure is the same everywhere, so on the output, the side of the tire, the same 1,200 Pascal acts. We have a bigger area, so therefore we have a bigger force. Now this principle looks like this. By applying a small force on a small area, we can lift up a big force over a bigger area because the pressure is the same everywhere. Now what makes this even more amazing is, as we've just seen, if I have 12 Newton and I have an area of 0.01 meters cubed at my piston, and at my wheel I've got a bigger area, 0.1 meters squared, I can apply 120 newtons. But as you know, your car has 4 tires. Since the pressure, if I apply it here, is going to be the same everywhere in the system, I'm not only taking 12 Newton and making it 120. I am taking 12 Newton and applying with 12 Newton, I'm applying 120 Newton at 4 other places. So effectively, from my 12 Newton, I have created 480 Newton, and we call this a mechanical advantage, where we use systems like this to increase our force. Now obviously the amount of energy cannot be lost, so the amount of energy used here will also equal the amount of energy on this side. So there's no energy loss or created here, but the force manipulating the area and the pressure, the force does get multiplied. So that basically covers the system. Just so that you know, this asterisk over here means that it's not examinable anymore. So this is just extra knowledge. This chapter, you might find questions on this in older papers, but currently we don't have hydraulic systems as part of our syllabus. Thank you. Goodbye.